All right, hey, so we're here looking at simplifying expressions with exponents, part 1. It's a review assignment. We're going to look at skills 44, 45, 46, and 47. You can see all of the properties of exponents that we have learned over the last week or so summarized here on the introduction page. I'm going to work on 2 different screens. So x to the 5th, and over there's x to the power of 6. These are being multiplied together. The exponents being, when the problem is multiplied, we can add those exponents. So take the exponent of 5 and the exponent of 6, add those together to get the new exponent on the x. And then the 2 y's, these both have the same base. So I get y to the power 2 and y to the power of 1. That's an invisible 1. Add the exponents, so 2 plus 1 is 3. That's the new exponent on the y. Question 3. So we've got x to the power of 7 and y to the power 2 on the numerator. Y to the x to the power of 5, y to the power of 3 are in the denominator. So the like bases, we can combine those. Since it's a division problem, subtract the exponents. I get x to the power 7 on the numerator and x to the power 5 on the denominator. So that means those 5 x's in the denominator are going to cancel 5 of the ones in the numerator. We just subtract to see what's left over. So x to the power of 2, 7 minus 5 gives us that new exponent of 2 in the numerator because there were more x's on the top to begin with. And then same process with the y's. Y to the power 2 on the top, y to the power 3 on the bottom. There are more y's in the denominator to begin with, so we can still subtract. 3 minus 2 is going to give us 1 y left over. But since there were more y's to begin with on the denominator, after those y's cancel, we're going to be left with that 1 y in the denominator. There's 2 of each type of problem, so I'm just going to do every other problem. And so here we go. 5 to the power of 7 raised to the power of 11, and write your answer in exponential form. Otherwise, it'd be a super gigantic number like millions and billions, and we're not going to do that. So multiply these 2 exponents together. If you raise a power to another power, you multiply the exponents. So it's going to be 5 to the power of 77. All right, so I've got a couple of things going on here. 7 to the power of 3 times 7 to the power of 6, that's inside the parentheses. That whole thing is being raised to the power of 9. I could do this in a couple of different approaches. I'm just going to follow the order of operations and do the stuff inside the parentheses first. Inside the parentheses, there are things with exponents. So we're going to combine them. They're being multiplied. They both have the same base. If it's a multiplication problem, those exponents get added. So I'm going to take this 3 and the 6, add those together to get 9. Then that still needs to be raised to another power, also of 9. In this case, I've got that green power of 9 raised to the blue power of 9. A power raised to a power means multiply the exponents. 7 stays as the base. New exponent will be 81. Write your answer in exponential form. Don't get your calculator and find out what 7 to the power of 81 is. I don't even think your calculator will be able to do it. It's going to be too big of a number. Okay, so another division problem, 6 to the power 9 divided by 6 to the power of 5. So that means 6 multiplied by itself 9 times on the top, 6 multiplied by itself 5 times on the bottom. Some of those 6's on the top and bottom are going to cancel. Subtract the exponents to see how many of those 6's will be left over. How many pairs of 6's are going to be canceled? Well, there's 9 on the top and 5 on the bottom. 5 are going to cancel. So there are 5 pairs that will be canceled. Then the answer in the next box left in exponential form. Again, don't get your calculator and multiply this out. So we just subtract the exponents. 9 minus 5 is 4. So this is going to be 6 to the power of 4. The base stays the same. It's just that exponent that changes. Since the top of the fraction, the numerator had the larger exponent, we don't need to worry about the denominator. The denominator canceled, it's 1, and we don't need to write that down. All right, simplify the expression completely. So I've got a couple of things going on here. Let's do the first part first. Okay, so I'm going to deal with the stuff inside the parentheses first. Inside the parentheses, there's actually nothing for me to do. But that first set of parentheses is being raised to another power. I need to get that 4 onto both parts of that expression inside the parentheses. So I'm going to attach the, well, let's just say it the same way. So that 5 has an invisible exponent of 1. We would never write that. That'd be silly. It'd be an extra thing to write, but that's what it means. So I'm going to take the red circled 4, that exponent, and multiply it onto each exponent of the things inside the parentheses. So the 5 has that invisible exponent of 1. 1 times 4 is 4. So I've got 5 to the power of 4. And then the y has an exponent of 14. So I'm going to multiply the 4 times 14, which is 56. Y to the power of 56. And then I'm going to bring down this y to the power of -9. Okay, so things that have the same base, I can combine. These two both have a base of y. If they got the same base, it's a multiplication problem. For multiplication problems, we add together the exponents. And it doesn't actually matter that one is a positive number and the other is a negative. It doesn't matter. We're just going to add them together. So 56 plus the -9 really is the same as subtracting. And if you wanted to get rid of the negative exponent in the first place, you could rewrite this as a fraction, and then you'd end up with a division problem, and you'd be subtracting or subtracting either way. This is faster. So those exponents, add them together. 56 minus 9 is going to give me, let's do the 5 to the power of 4 first. That stays there. And so 56 minus 9 is 47. And these directions don't say to enter your answer in exponential form. So you could multiply out 5 to the power of 4, 5 times 5 times 5 times 5. It's a big number. You could probably leave it as an exponent. There's so much to erase this time. All right. So this one is similar. A to the power of -4, b to the power of 3. That whole thing being raised to the power of -3. So I have two different bases inside the parentheses. I'm going to take, so I can't combine the bases, a base of an A and a base of B. So inside the parentheses, there's nothing for me to do. Take this, this red circled power, and I'm going to multiply it onto each of those exponents. This is a power raised to another power. The power is inside the parentheses being raised to the power outside of the parentheses, and that means we can multiply. So -4 times -3. Let me pay attention to what I'm writing. That's an A. -4 times -3 is +12. And on the B, +3 times -3 is -9. Okay, we're not going to leave our answer with a negative exponent, so we will need to continue simplifying the B. So a to the power of 12, I'm going to leave that alone. Negative exponent means I'm going to make this, I'm going to think of it as a fraction. Anything with a negative exponent moves locations in the fraction. So if it is part of the numerator with a negative exponent, I'm going to move it to the denominator, and then it'll be the same thing except positive exponent. So b to the positive 9 is going to move down there and be part of the denominator. The end. Or 15. All right. So I've got I've got 3 parts going on here. So I have 4x to the power of -2 on the top. I got 5p to the -9 on the bottom. These are actually not bases at all. There is no exponent on the 4. There's no exponent on the 5. These are just numbers. That's a fraction. We're not going to do any weird exponent-y stuff. It's a fraction. If you can reduce a fraction, you should reduce the fraction. In this case, I can't reduce 4 over 5. It's already reduced, so that's going to stay exactly the way it is. 4/5. You might get a problem that's got a fraction that you can reduce, and in that case, you do need to reduce it. X to the power of -2, that's a negative exponent. The directions tell me to simplify right with positive exponents. I can't leave it there. So anything with a negative exponent, it's going to move to the other part of the fraction. So the -2, x to the power of -2 is in the numerator to begin with. I'm going to move it to the denominator, and now it's going to get a positive exponent. The p also has a negative exponent. It means it's going to move also. So it started in the denominator with a negative exponent. I got to move it up to the numerator, and now it'll have a positive exponent. So final answer, 4 p to the power of 9 on the numerator over 5 x squared as the denominator. Last one, very similar to the previous one, 5m to the power of -8 and 6r to the power of -3. Again, the 5 and the 6 do not have exponents. Don't do any of the exponent principles. These are just numbers. It's a fraction. If you can reduce it, you have to. 5 over 6 does not reduce. So I'm going to leave that alone. Can't have any negative exponents in my answer, so that m to the power of -8, since it has a negative exponent in the numerator, I move it to the denominator, and now it's going to be positive 8 for the exponent. R to the power of -3 has a negative exponent as part of the denominator. I'm going to move it up to the numerator, positive exponent. The end. All right. Do good mathing.